Hello, geometry students. This is your lesson for section 6-6 in 15 minutes or less. Missy McCarthy, Okemos High School math instructor. In this particular section, we're going to bring in two more and our final two quadrilaterals, which are kites and trapezoids. So we're going to solve problems involving those. Now, you think you might know what a kite is, but a kite in geometry is something different. A kite in geometry has particular characteristics. One of the characteristics of a kite in geometry is that it is definitely a quadrilateral that has exactly two pairs of congruent consecutive sides. So the definition of a kite would be a quadrilateral, four-sided figure, with exactly two pairs of congruent, consecutive, that means right next to each other, sides. So you can see by the markings here, AB is congruent to BC, and those two sides are consecutive, and also AD is congruent to CD, and those two sides are consecutive. They share a vertex. So they share a vertex of an angle, so that makes them consecutive. There's two properties of kites that we're going to focus on. The first property is if a quadrilateral is a kite, then its diagonals are perpendicular. So this is very similar to the property of rhombuses. In rhombuses, the diagonals are perpendicular, but they're also perpendicular in a kite. And then also, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So B and D are congruent, but A and C are not. That's why it says exactly one pair. So those are our two properties of a kite. So let's apply those properties. In this particular problem, we have a kite, ABCD, and angle DAB is 54 degrees. So DAB, this entire angle here, is 54 degrees. And then it also says that the measure of CDF is 52 degrees. CDF, that's this guy here, and that is 52 degrees. Now we can use one of our properties of a kite to say that CFD is a 90-degree angle because the diagonals of a rhombus are perpendicular. So if we're looking for the measure of angle BCD, where is BCD? BCD, that's this whole angle here. So what I'm going to do is 180 minus 90 minus 52, and that gives me 90 minus 52, which is 38. So we know this angle here is 38 degrees, and because the diagonals of a kite bisect this pair of the opposite angles, this guy is also 38 degrees, making the measure of angle BCD twice 38, or 76 degrees. Now if we're going to find the measure of angle ABC, that's that whole angle here. Well, we know this is a right angle. We know this is 38, so we can find this one here. So we would do 90 minus 38 degrees, and we would know that this is 52. Okay, and then also we know that this is 90, and this one is half of 54, which is 27. So if we do 90 minus 27, let's see, 80, 70, is it 63? So this would be 63. So then, or 53, my bad. I'm going to say 53, 63, 73, 80. Oh, no, I was right. Okay, so if we have that, then we know that the measure of angle ABC is the sum of those, so it's 63 plus 52. Know each of these are 38, so BCD, if this is 38 and this is 38, BCD is 76. For part B, we wanted to find ABC. So ABC, that's this big angle here. Well, if this guy is 52, this guy is also going to be 52. If this whole thing is 54 and this diagonal bisects it, that makes this 27. If that's 27, that makes this 63. And if that's 63, then 63 plus 52 makes that angle 115. And then lastly, we wanted to find FDA. So that's FDA. Well, we just found that this was 63, so that means FDA has to also be 63, and that's why we had that there. Okay? All right, any questions about a kite? Anything at all? No? Okay. All right, so then we went on to a trapezoid. It's a quadrilateral that has exactly one pair of congruent sides. I'm sorry, not congruent sides. Exactly one pair of parallel sides. Okay, so there's a picture of a trapezoid. We can see that the base angles are formed by a leg and one of the bases, which are the parallel sides. And the isosceles trapezoid is just a trapezoid with congruent legs, where the legs are congruent. So what we're going to see is the isosceles trapezoid has a lot of the same properties as an isosceles triangle. Okay, so that's your trapezoid. All right, so the trapezoid has a couple properties. One is, if it is an isosceles trapezoid, then the base angles are going to be congruent. So you can see the red angles are congruent and the blue angles are congruent. And that's only if the legs are congruent, just like an isosceles triangle. This theorem says, if the base angles are congruent, then it's an isosceles triangle. So if you have a trapezoid with A congruent to D, then you can conclude that AB is congruent to CD. That's an isosceles trapezoid. I think I said triangle. I meant to say trapezoid. And then lastly, a trapezoid is isosceles if and only if its diagonals are congruent. So if it's a trapezoid and BD is congruent to CA, it's okay for you to conclude it's isosceles. Or if it's an isosceles trapezoid, then you know the diagonals are congruent. So those are the three properties of an isosceles trapezoid. All right, so if we're looking at this example here, and the writing is already there because I thought it was recording yesterday, we've got this triangle here, I'm sorry, not triangle, trapezoid here, and we know it's isosceles because BC is the same as AD, and we know that CD is parallel to AB. So that means the base angles are congruent. So if C is 100, that's 100. And these base angles are congruent, A and B, but we don't know what they are, so that's why I called them X. Now what's the sum of all the angles inside any quadrilateral? 360. So 200 plus 2x is equal to 360. That means 2x is equal to 160, and x turns out to be 80. So that means both angle A and angle B are 80 degrees. Okay. ¿Tienen ustedes preguntas? ¿Sí? ¿Cuál es tu pregunta?
What's your question?
You said we or sí.
We means yes.
I know. I said, do you have any questions? And you said yes.
I comprehend the Spanish.
Then don't answer. Good. All right. This shape here is another isosceles trapezoid. And we were told something about the diagonals. So we knew diagonal FM was 32.7. So I wrote that along the line here. We knew that KB was 21.9, but we didn't know what JB was. So I called that X. So we know that I do that a lot. We know that 21.9 plus X had to be equal to the other diagonal, which is 32.7, and then if you subtract, you get X is 10.8. So that's the length of segment BJ, 10.8. That's just using the fact that in an isosceles trapezoid, diagonals are congruent. Okay, Okay, then the last thing we learned was something similar to the midsegment of a triangle. And all this says is, if you take the midpoints of any trapezoid, it doesn't have to be isosceles, any trapezoid. So X is the midpoint of this leg, Y is the midpoint of that leg. If you connect those midpoints, that segment that you have formed is called a midsegment. And the midsegment has a couple of properties. First property, the midsegment is parallel to the other bases. And the second property, its length is the average of the lengths of the bases. So add the two bases together and divide by 2, and you have the length of xy. That's it. So in this particular problem here, they give you the midsegment is EF. We know it's the midsegment because E is the midpoint and F is the midpoint. We need to find the length of EF. We know that it's parallel to those. And then the length is going to be half of the sum of the bases. So 1/2 of 80 plus BC, 1/2 of 13.5 plus 8, 1/2 of 21.5, and it is 10.75. So half of 13.5 plus 8, which is half of 21.5, which is 10.75. Yes? That is a theorem, the trapezoid midsegment theorem.
So, like, how would
you would probably have to prove it. I would imagine you could do a coordinate proof, and that would work. Or you could prove it by using the fact that these are parallel, and then, I don't know. I'm thinking coordinate proof would be easiest. Because you could definitely show that this was parallel to these by a coordinate proof, because they have the same slopes. And then if you do the distance of AD and the distance of BC, and then add them together and take half, I bet it would be equivalent to the distance of XY. So that's probably what I would do. That's not to say this is the only way. That's what I would do. Okay? All right, anything else? Okay, I'm going to have you